Hello, Algebra 2 class, and welcome back. Today we're going to be looking at Chapter 4, Section 5 from your Algebra 2 textbook. That section is on solving exponential and logarithmic equations. We have two main objectives for today. The first is to solve exponential and log equations, both algebraically and then also using our graphing calculators. And the second objective is going to be to solve some application problems involving exponentials and logs. So we'll jump right into the steps for solving an exponential equation algebraically. There are four main steps here. First one is we're going to isolate the exponential. And what that means is we want to get the part of our equation that has the variable exponent alone. Step two, we're then going to take the log of both sides. Technically, we can do any log base, but we're going to be using log base 10, again, because that's the one on our calculator. Step three is we're going to apply the power property of logs in order to move our variable out of the exponent. That's the whole reason for step two. And then step four, once we've gotten x out of the exponent, we're going to solve for it. So let's look at an example. Here we want to solve our exponential equation. Now, we will be rounding our answers in these problems for the most part, but it's important that as you go through the problem, you don't round at intermediate steps, only round your final answer. So step one, remember, is to isolate the exponential part of your equation. In other words, we're going to find where's the part that has the variable exponent and get that alone. Well, in this problem, that's right here. Here's the exponential piece of our equation. We need to get that by itself. Remember, this 0.2x is only attached to the 3, not to the 7. Well, in order to get rid of that times 7, we're going to divide both sides by 7, which will bring us here. 3 to the 0.2x equals 12 over 7. Again, leave this as 12 over 7. That's exact. Do not round it yet. And now we're going to do step 2, because our exponential is alone, which says to take the log of both sides of this equation. So that's exactly what we'll do. We'll go ahead, we'll take the log of this side of the equation and the log of this side of the equation. Remember, the whole reason for doing this is so that we can get our variable out of the exponent, because now we can use our power property of logarithms, which says that we can take exponents inside of logs, in other words, this whole piece, and bring them out front. So to rewrite that, we now have 0.2x times the log of 3 equals the log of 12 over 7. Now we're on to our final step, step 4, which is just to get x alone. So the first thing we have to do is start dividing pieces away. Specifically, we're going to divide away the log of 3, which will leave us with 0.2x equals log of 12 sevenths over log of 3. And then x is almost by itself, but not quite. We have to still divide away this 0.2. So x is going to end up being log of 12 sevenths divided by log of 3. And this is going to look a little messy because we're in a fraction of a fraction here, but I think this is the most intuitive way to write it, all divided by 0.2. That's pretty much exactly how you will write this in your calculator as well. You will type in log 12 divided by 7, close parentheses, divided by log 3, close parentheses, divided by 0.2. And in the end, you should come out with this number here, 2.453, because we were asked to round to the nearest thousandth. Now, one more example for you. Again, we just have to solve this exponential equation and round to the nearest thousandth. So step 1 is to isolate the exponential part, which in this case is our 11 to the x minus 1. Well, there's two parts to get rid of this time, the 4 and the 2. The first one we have to go after as we work our way in towards the exponential is to subtract 2 from both sides, which will leave us here. 4 times 11 to the x minus 1 equals 7. We'll now divide both sides by 4. So we get 11 to the x minus 1 equals 7 divided by 4. Again, we're not going to round that. We're going to decimal that. We're going to leave it as a fraction. Now we've isolated the exponential. We're going to make a log of both sides. So we will now have log of 11 to the x minus 1 equals log of 7 over 4. And again, the reason we do this is so we can now do step 3, which is to bring our exponent out front. So we'll have x minus 1. Make sure you keep that whole exponent group together, times log of 11 equals log of 7 over 4. And again, we're to the part where we have to solve for x. So we'll divide away this log of 11 first, leaving us with x minus 1 equals log of 7/4 over log of 11. And then the last thing we have to do in this case is not divide again, but to add 1 to both sides. I'll move over here a little bit. X will come out to be the log of 7 over 4 over log of 11 plus 1. And again, I believe when you go ahead and do all that math out on your calculator, you should get this number right here, which is 1.233.